Hold it over, turn it over, rotate. Yeah, there you go. See, I want to make a puddle right there. Look at that. I want to make a puddle of solid. It tells me when it's point it down. Point it down. Like that. There you go, little war. Oh, you okay? Yeah. Take off the wires. Okay, Troy. Yeah, I don't really feel stuff like that, so. Do what? Yeah. You don't feel heat? Nah. I'm no kidding. I've been burnt by wood stoves and not even knowing it. That's something else. Here, will you hold this?
No. We're gonna have to do something because that's not gonna be big enough for the other.
This is temporary. Remember, we're gonna put that fuse block, okay? And that fuse block is gonna come out, and you can put as long a bolt as you want to on it. And that'll be more amps than you're gonna pull out of this or that one at the same time.
That'll work.
And then we can put your DC circuit on that too.
What about the negative terminal? It's going to be as short.
No, you would directly connect it.
No, but there's the terminal in the battery is too short for that many wires. On the negative lead, you can't fit another wire on
right there. Directly off of the charge control terminal.
But then we're not taking off the opposite side of the battery bank.
I never have once.
I know, but that's what everybody keeps telling me.
Not gonna run my house.
I know, but
we can do it your way.
It's
But we're
not
gonna
my
have to
way.
put another bolt here. Now, what we need is a piece of steel, that aluminum, and we're gonna have to bolt it to this. Okay?
we could do
And
what
then
I
we
did in the
extend it
house.
out
We
and
could
put
do
another bolt
what
here.
I did in the house and run the one inverter to the leads of the other, because the wire's big enough. I had two leads in the inverter.
What do you mean? Just take
Run that
and
one.
make a junction right here?
No, where's the green inverter?
It's outside.
Hook that one up to the battery bank,
Mm-hmm.
and hook those leads to that inverter's leads. So you got,
That's fine with me.
that way you're not changing anything here.
So you want to put that inverter right here? Let's go ahead and mount it.
I thought we were gonna cover that hole.
Oh yeah, we're gonna mount here.
Yeah. Then I'll just plug that hole from inside.
Hold up for just a second. It's not very heavy. My inverter weighs 150 pounds.
Oh, is it bigger than this? Like physically?
It's about that wide, long, this thick,
Oh boy.
this tall, and it's
You
on
wouldn't
the
just
wheels.
be reaching over and
No,
putting
it's
it
on the
wood.
floor. It's on wheels.
So, let's get it on straight.
Let's keep it parallel with that one.
Right here?
Yeah.
Okay, you're gonna have to guide me. Oh boy.
Right there's probably gonna do just fine.
Alright. But you can
If I put a screw on it, it might
Yeah.
be beneficial, right?
Yeah. No.
We gotta level it. You need to go up.
I think we're good. Can you hit, is that straight? A little bit more.
Just too much right there.
Okay, now get one on the bottom. Okay. And then that one will run to here, and that'll go to here, and then we got no more problems. Right? And then everything's in one spot where it should be. I like it that way. So we got no water in the house.
We need water back immediately, right?
What's that?
Where's your we need to set up the water back. And this has got a switch right here, Troy.
I'll be right back.
Okay. If you don't want to do that, we're going to run these wires back over here. I'd rather use this terminal. Where's that terminal? It's not plugged up yet. Where's all this? Doesn't that make it difficult?
Last log.
You don't want to take it directly off of the batteries. So either this end will be a lot better, period. Grab the tool bag here. Oh. So we're gonna have to reuse terminals,
Yeah.
and
Now I've got some heavy wire here.
well, the wire's not gonna be a problem.
No, I mean with the terminals on it. That's longer than what we want to use, so I don't know.
I'm just gonna reuse this wire. We're gonna staple it to the wall there.
Okay. Actually, that wire's almost just right. It'll be fine.
Oh, this
You're
is
not gonna cut
overkill for the inverter.
No, is it gonna go? Hold on, before you cut. Let it come down.
Oh, you gotta go on the bottom.
Yeah.
Okay, that'll be fine.
I'm gonna stop there. I think that's perfect, right? I think that's perfect.
Pretty darn close,
Yeah.
except you got a screwdriver attached to the negative side of this motor
Huh?
that will connect right there.
Move this over again.
That's probably best.
Alright. Not a problem. I don't like where it is now anyway.
Did you hear my kids wanting some candy, huh? Let's see, where is the wires that goes to this inverter?
Right behind you, I think.
Now, these are crimped on pretty good. And soldered. This one is not soldered on this side. There, sorry. This is going to be the negative side. Well, this this? No, it's the
Yeah, it's
Jordans.
that one.
Soldered side. I'm gonna put it on the inverter because of corrosion. Let me hook up the positive side first because you taught me that.
No, you. Yeah.
I'm a alternating current guy
Yeah.
mostly. There isn't many DC batteries on a heat and air conditioning system.
No. They always hook the ground up last.
Yeah.
And
I just want to
disconnect
make
it
sure it
first.
reaches
Yeah.
good and it's not nice and organized.
Yep.
Kind of get it ready. There goes my torch into the dirt.
And like I said, after I saw a battery blow up in a kid's face, I'm always very, very careful.
I was nearly electrocuted with alternating current.
Oh yeah, I've been electrocuted before.
I know you had it. You'd be dead. Because the definition of electrocution is death by electricity. You've been shocked.
Yeah, for 20 minutes.
20 minutes? How'd you live it?
What happened was, I was working with a bad extension cord in the rain.
Oh,
I was under a carport. It had the plastic roofing like this, and it was leaking right where I was working.
This is metal.
Yeah.
Corrugated.
Yeah, corrugated, yeah. And I had to do an alternator on a car, a minivan, and it was my cousin's, and I had to pry the motor up while I was trying to get the alternator out.
Uh-huh.
My arm hit against the wet ground and the light, and I actually fried the extension cord, never popped the circuit. I melted an extension cord. The only way I got loose was the bar eventually slipped and knocked me off.
He's coming out in a minute.
20 minutes?
Yeah. I've lived through a lot of stuff that would kill a normal person.
I was working on a heat pump one
Actually,
day.
as soon as he comes out, I gotta do some video.
That's when I was younger.
Yeah.
It was many, many years ago. And I was working on the heat pump. I changed the compressor. Okay? And I was having trouble with the start, so I put a super booster on it. Okay? And I was taking it back off. Because, you know, I got the compressor hot from how I turned it on, turned it off, doing different tests, turn it on, turn it off.
Yeah.
After my different tests I had completed, you know, I was determined, when I was doing the final charge, and it wouldn't start because it was thermal overload. And then when I tried to start it, it wasn't kicking. So I put a capacitor on it, super booster, and my finger wrapped around the capacitor.
Oh.
And I couldn't let go of it. And
Yeah.
I'm talking about I was shaking, and the unit was shaking.
Yeah.
And it was shaking violently, okay?
Yeah.
And my knees was saturated in water where it was 100 degrees, and the unit beside me was pumping water outside beside that unit, because there was 2 units on that house. My right hand was grounded to the neutral, the ground circuit that goes to the breaker panel. My knees was grounded in water, and it was 100 degrees, so I was sweating. And when I grabbed that capacitor, it just wrapped my hand around it, and I couldn't let go of it.
Oh, yeah.
And I was on 230 volts for about 30 seconds. And I sat down for about an hour after that with metal in my mouth for about 3 weeks.
Yeah.
It was crazy.
Oh, yeah. Those capacitors are crazy.
It was 230 volts coming into the capacitor, of course.
Yeah.
I mean, you know, you could touch this,
Yeah.
12-volt circuit. You know, DC doesn't have.
Yeah.
Doesn't
Amperage.
allow a lot. It's not the amperage; it's the voltage that gets you. See, this
Yeah.
has got 900 amp hours or something like that.
Yeah.
And you know, if you touch the solar panels coming in, it's 80. You know, 80 to 120 volts with 4 amps. You'll
Yeah.
know it. And you touch this one,
Yeah.
you can't even feel it.
Yeah.
It's
I mean,
because of resistance. Your skin has
Yeah.
a certain kind of resistance. Alternating current requires less resistance to travel real far.
Yeah.
And that's why alternating currents used to transmit power through long distances. From Nikola Tesla, he discovered electricity like that.
Yeah.
I love Nikola Tesla. He's awesome.
Yeah, just like most cars, 40,000 volts. Some are
On the
even 60.
transformer for the coil packs, yeah,
Yeah.
yeah.
I've been shocked by plenty of those.
Shocked. That's the right word to say. Shocked. Electrocution.
Yeah.
I'm glad to be alive. I remember those days.
Do you?
It's funny that my wife actually knows of a lady that owns that house after I worked on it. Before I even met, before
Yeah.
my wife even moved over into the place where I live. You know, it's you know, she was working in Mississippi before she moved here. She was a blessed thing, you know.
Yeah.
So we've got this up and going.